There is a patch of ground on the moon where sunlight has never landed. Not dark tonight, not dark this month. Never. Not once since the moon took its present shape, no photon of direct sunlight has touched that floor. And if you go outside tonight and look up, you are looking at the object it sits on. Later this month, if the schedule holds, China is going to fly a robot into it. And I want to be careful with you from the very first minute, because this story is being told badly almost everywhere. Nearly every version says the spacecraft is landing in the crater to find the ice. That is not what happens. The lander stays in the light. Something else goes over the edge. And the thing everyone assumes it will find down there may not actually be there at all. Because 5 months ago, a paper went looking for exactly that ice and came back with nothing. Let me take you through it properly. Start with the place, because the place is the strangest part. On Earth, nowhere is permanently dark. Our planet is tilted about 23 degrees, so the poles get 6 months of sun and 6 months of night. And even the deepest polar crater eventually gets a low sun sweeping across it. The moon is different. Relative to its orbit around the sun, the moon is almost perfectly upright. The sun never climbs more than about 1.5 degrees above the lunar poles. 1.5 degrees. Hold your thumb up at arm's length and you have covered more sky than that. And when the sun never gets more than a thumb's width above the horizon, anything with a raised rim casts a shadow that never moves. The crater floor sits below the horizon of its own wall, permanently. There is no season that fixes it. There is no rotation that fixes it. Scientists call these permanently shadowed regions, and the moon has thousands of them. So how cold does ground get when the sun has never reached it? NASA's Lunar Reconnaissance Orbiter measured the floor of one of these craters at minus 248 degrees Celsius. That is minus 415 Fahrenheit. And it set a record. Not the coldest place measured on the moon, the coldest place ever measured anywhere in the solar system. Colder than the surface of Pluto, colder than anything our instruments have found out among the outer planets. There is ground on the moon that is colder than Pluto, 25 degrees above absolute zero. And it is close enough that a rocket can reach it in a few days. That cold is the entire reason anyone cares. A place that cold is a trap. Any water molecule that wanders into it, delivered by a comet or a wet asteroid, or created by the solar wind striking the soil, sticks and never leaves. It cannot evaporate. It cannot escape. Over enough time, the theory goes, those traps should have collected ice. And that ice would be the most valuable substance in the solar system. Because water is drinking water. And it is breathable oxygen. And split the right way, it is rocket fuel. A base at the lunar South Pole does not have to carry any of that up from Earth if the ice is real. Which brings us to the machine, and to the part almost everyone gets backwards. This is Chang'e 7, and it is real hardware sitting on real ground right now. The spacecraft was flown from Beijing to Hainan Island aboard an Antonov AN-124 heavy lifter and arrived at the Wenchang Launch Center in April. Its Long March 5 rocket came separately by ship and was trucked in from the port over 2 days in July. 8,200 kilograms of spacecraft under a 5.2-meter fairing. The launch windows that airspace notices point at open on the 24th of August. Though I will say plainly that China does not announce its launch dates in advance, so treat that as the best available reading rather than a promise. The agency's own language is simply the second half of 2026. And Chang'e 7 is not one spacecraft, it is 4. There is an orbiter, which stays above and maps. There is a lander, which comes down. There is a rover, which drives. And there is a fourth machine, which is the one this entire video is about, and which does something no spacecraft has ever done on another world. The target is a peak near the southeastern ridge of Shackleton crater, and about 88.8 degrees south. Shackleton is 21 kilometers across and over 4 kilometers deep, and its floor is one of those permanently shadowed places. The lander is aiming for accuracy better than 100 meters, using a landmark image navigation system. And here is a detail I find quietly wonderful. Its solar panels are mounted vertically, standing up on end instead of lying flat. Because at the pole, the sun never climbs overhead. It only ever grazes the horizon. A flat panel would catch almost nothing. So the engineers stood the panels up like sails to catch a sun that never rises. Now look at where that lander is going, not into the shadow, onto the illuminated rim. The lander, the rover, and the fourth machine all come down together on ground that gets sunlight, because the mission needs power and it needs to talk to Earth. The shadow is right there, over the edge, a few kilometers away. And then the fourth machine goes in alone. It has 6 legs and it flies. It carries its own fuel and its own rocket thrusters, and it is designed to walk, climb, crawl, and jump. Its deputy chief designer described it as an extremely smart robot, capable of leg trajectory planning, and it uses active shock absorption so it can land on a slope without tipping over. It is built to make at least 3 powered leaps, and reporting on its range varies quite a bit, so I will not put a hard number on how far it can go. What matters is the direction. It launches itself off the sunlit rim, flies over the edge into ground that has been dark for an extraordinarily long time, and lands in the cold. Then it does something rather beautiful. It walks away from its own landing site, on its legs, because its own rocket exhaust has just disturbed the ground it came down on, and the ground is the thing it came to sample. It walks a short distance to soil nothing has touched. It drills, it seals the sample, it heats it, and it reads the gas that comes off with a mass spectrometer. The instrument is called the Lunar Soil Water Molecule Analyzer, and its specification is a detection limit better than 1/100% by weight. It can also measure the ratio of hydrogen to deuterium, which is the part that made me sit up, because that ratio is a fingerprint. Water from comets carries a different isotope signature than water made in place by the solar wind. So this machine is not only asking whether there is water down there, it is asking where the water came from. And now the part I promised you, which is the reason this mission matters more than the coverage suggests. Nobody has ever touched lunar polar ice. Not once. Every confident claim you have ever heard about water at the moon's poles comes from 3 kinds of evidence, and none of them involve a machine putting an instrument into the ground. The first is an impact. In October 2009, a spent rocket stage was deliberately crashed into the permanently shadowed floor of Cabeus crater, and a second spacecraft flew through the debris plume behind it, sniffing what got thrown up. It found a signature consistent with water. The second is orbital spectroscopy. An instrument aboard India's Chandrayaan-1 spotted the infrared fingerprint of water ice and reflectance data in several thousand pixels at the very surface, a depth of a few millimeters at most. The third is neutron counting from orbit, which infers buried hydrogen. And that data is stranger than most people realize. Of all the large permanently shadowed regions on the moon, only 3 showed significant neutron suppression. Only 3. Many other permanently shadowed craters showed no meaningful difference from ordinary sunlit ground at all. And in March of this year, a paper led by a researcher at the University of Hawaii used a camera specifically designed to see inside shadowed craters, looking at 6 of them. It found no widespread surface ice above its detection threshold. Sit with that for a second, because it reframes the whole mission. 5 months before this launch, the best look anyone has taken into those craters, came back and said the surface ice is not obviously there. There is a second complication, and it is a good one. There has long been an assumption that these shadows are billions of years old, and that they have therefore had billions of years to collect ice. The 2023 study looked at how the Moon's spin axis has actually moved over time, and concluded that the average permanently shadowed area is at most about 1.8 billion years old, with most of them younger than that, which shortens the collection window considerably and shrinks the amount of ice you would expect to find. So we have a situation that I think is genuinely thrilling, and it is the opposite of the story usually told. This is not a mission flying to a known treasure to scoop it up. This is a mission flying into a place we have never touched, to settle an argument that has been running for decades and that recently got harder, not easier. The Hopper is the first machine ever built to go down there and ask directly, and it could come back with nothing. There is a race running behind all this, and it is worth knowing where everyone stands. The American equivalent, a polar rover called Viper, was canceled in 2024, then revived, and is now aiming for no earlier than late 2027 aboard a commercial lander. The Artemis program was restructured in February of this year, and the revised third mission will no longer land at the South Pole at all, with a crewed polar landing pushed later. China, meanwhile, is targeting a crewed lunar landing before 2030, and Chang'e 7 opens the phase of its program aimed at a robotic research station at the pole, with Chang'e 8 following at the end of the decade to test whether lunar material can be used to build and refuel. Which is why a six-legged robot jumping off a crater rim is not a stunt. It is a survey for a construction site. So here's where we are, and I will not dress it up. Sometime after the 24th of August, if the window holds, a rocket lifts off from Hainan Island. Roughly 3 months later, if everything works, a lander touches down on a sunlit ridge near the bottom of the Moon, its solar panels standing on end to catch a sun that skims the horizon. And then a machine with 6 legs fires its thrusters, jumps off the edge of the light, and comes down in a place that has never had a sunrise, 25 degrees above absolute zero, in the dark. It will drill, it will heat what it finds, and it will radio back the first direct answer humanity has ever had to a question we have been arguing about from orbit for the better part of 20 years. I genuinely do not know what it will say. Neither does anyone else. That is what makes it worth watching. I will be following it, and when that answer comes back, you and I will read it together.